Hi guys, let me take a few minutes to go over the last three multiple choice questions. Number 7, suppose a student is randomly selected from your school. Which of the following pairs of random variables are most likely independent? Meaning that the likelihood of one of these outcomes does not impact the likelihood of the other outcome. So here, students' height, students' weight. I would offer that taller people may tend to weigh more, shorter people may tend to weigh less. I doubt those are independent. PSAT math score and PSAT verbal score, I would offer that there's probably a link between those two also. IQ and GPA, maybe a link. Hours spent on homework, students' GPA. Again, at least we could tell a story where there is a plausible link there. E is the best answer here. Students' hours spent on homework versus students' height. That is hard to tell a story where you are making some plausible connection between those two random variables, X and Y. Question number 8. 17 people have been exposed to a particular disease. Each one independently has a 40% chance of contracting the disease. A hospital has a capacity to handle 10 cases of the disease. What's the probability that the hospital's capacity will be exceeded? Well, the first observation here is that we have a binomial random variable. So we have a total of 17 trials with a success probability of 0.4. So there are two outcomes. You do or don't contract the disease. A fixed number of trials at 17. We have a fixed probability of, quote, success, 40%, and we believe that these individuals independently contract that disease. So all of our conditions are met, and we are interested in the probability that the hospital's capacity is exceeded. Their capacity is 10, so I'm interested in the outcome that X is greater than 10. So that includes outcomes of 11 or above. So what I am interested in are the outcomes 11, 12, 13, 14, 15, 16, and X equals 17. What I am not interested then in are the outcomes from 0 to 10. So the simplest way to calculate this would be to take 1 minus the probability that X is less than or equal to 10, and that can be calculated using the the binomial CDF command. So that is under second variables. The binomial PDF command would be used to calculate one probability for exactly one outcome. Here I have a stream of outcomes from 0 to 10 whose probabilities I want to calculate and add up. So we're going to use the CDF command. That C stands for cumulative. We are accumulating all of the probabilities from X equals 0 to X equals 10. There are 17 trials. The success probability is 0.4. And I am interested in up to and including 10 successes. There we go. Now be careful, this is not the final answer. That's 0.965. So that answer needs to be subtracted from 1, and then we'll be good to go. So don't be fooled by answer D. It's 1 minus that. That's answer B. 1 minus the 0.965, that's 0.035. All right, the last question, last multiple choice question. The weight of tomatoes chosen at random from a bin at a farmer's market follow a normal distribution. So let's see, we'll call each of these X for the weight of an individual tomato. They are distributed normally. There's my shape. They have a mean of 10, so I will include that, 10 ounces. A standard deviation of 1 ounce, so I've included all of that information. There's the distribution of one individual tomato. Let's say we pick 4 tomatoes at random from the bin, and we want their total weight. The random variable T is distributed how? Well, let's think about what T is. T represents a combination of 4 X's that have been added together. So every one of those X's is a random variable which represents the weight of a randomly selected tomato. Each one of those X's then has a mean of 1 and a standard deviation of 1. So notice our random variable t is a linear combination of these four variables. Those four variables are all normally distributed, so that means that the linear combination of them will also be normally distributed. So the answers cannot be D or E. Those are binomially distributed. So it has to be normal. That's A, B, or C. So the mean for each random variable is 10. So the total mean I can literally find by adding up the 10 four times. So the mean then for t is 40. So that eliminates answer A. I'm now down to answer B. Something important to think about here. We have to believe that the weights of these tomatoes are also independent of one another. If that is the case, then be careful. You can't add the standard deviations, but we can add the variances. So the variance then for t, literally the variance for the first tomato, well, the standard deviation is 1, so 1 squared is, again, 1. That's the variance for the first tomato. All of the tomatoes then will have the same variance of 1. So the combined variance in this case, I need to write it as variance. Variance is a squared quantity. So this expression represents the variance, 1 squared plus 1 squared plus 1 squared plus 1 squared. That means my variance is 4, and to find the standard deviation then, I will take the square root of that combined variance, and that gives me 2, and that verifies that the answer is B. The shape is normal. The center for the total weight is 40 ounces. The standard deviation is 2 ounces. Answer B.